Hey geometries, this is Mr. Bloom. This is lesson 6.2, properties of parallelograms. So we're doing properties of parallelograms, and maybe perhaps I need a pointer. So let's get that pointer up here for you all so you can see what I'm talking about and where I'm pointing to. Okay, so now let's get that there, and we'll get that going. So here's the deal. Our objective, students will be able to use relationships among sides and angles of parallelograms. Use the relationships among diagonals of parallelograms. So we're going to work with sides and angles of parallelograms, okay, and use the relationships among the diagonals of parallelograms. All right, that'll be cool. So let's get this moving. So today, looking at this and get myself another pointer here. All right, so I got myself another pointer. And our definition for today, a parallelogram is a quadrilateral with both pairs of opposite sides parallel. Both pairs of opposite sides are parallel. This is the definition of parallelograms. Okay, now essential understanding, parallelograms have special properties regarding their sides, angles, and diagonals. Okay, now theorem 6.3. If a quadrilateral is a parallelogram, then its opposite sides are congruent. So if I know this is a parallelogram and opposite sides are parallel, therefore we know that the opposite sides are congruent all the time. It's a fact, Jack, by theorem 6.3. So well, let's use that fact. Okay, I am now looking to find the values of the variables in. This is a really fancy way to say parallelogram, by the way. Parallelogram DEFG. Now, DG is equal to 2x plus 2. And DG is across from EF. So DG and EF are going to be equal to each other because we just learned about 6.3 that sides in a parallelogram are congruent. And DE is 3x plus 1, DE, and GF is 2x plus 6. So I know these things. DG is equal to EF. So now I can say 2x plus 2 is equal to 3x minus 3. And now at this point, after I use my properties, I am in algebra land. So I solve. 2 is equal to x minus 3 because I subtract 2x from both sides. I'm going to add 3 and 5 is equal to x. Now, they ask me to find the values of the variables. They don't ask me to find the lengths of the sides. But if I actually plug my values and my variables back in, I can determine if I'm right. So 2 times 5 is 10 plus 2 is 12. 3 times 5 is 15 minus 3 is also 12. So I'm right. So I'm done with that one. I'm pretty darn happy. I've checked my work. Now, I also know that DE is equal to GF based on 6.3. So 3x plus 1 is equal to 2x plus 6. And I subtract 2x and x plus 1 is equal to 6. And I subtract 1 and x is equal to 5. Now I plug that back in and I find out that since I've got 5, I plop that in. 5 is 15 plus 1 is 16. This is 16. And 5 times 2 is 10 plus 6 is also 16. So this checks out as well. Now, keeping in mind, anytime that we have the same variable in a problem, the variable should be consistently the same all the time, and we just showed that it was in this problem. But now, as we move on, we're keeping in mind that we use the fact that this was true, and we use the fact that this was true based on theorem 6.3. Opposite sides in a parallelogram are congruent and therefore equal. So now, your turn. Okay, it's your turn. Go ahead. Turn me off. Okay, hopefully if things went well, let's investigate the diagram. DG, EF, if this is a parallelogram, and it is, they are congruent. Therefore, DG is equal to EF, and by substitution, I know 3x plus 2 is equal to 5x minus 4. I subtract 3x from both sides, and I get 2x minus 4, and I add 4 to both sides, and I get 6 is equal to 2x, and I divide by 2, and I get 3 is equal to x. Now, I further know that DE and GF are equal, okay, because of theorem 6.3. GF. So I got 4y plus 8 is equal to 5y. I subtract 4y and find 8 is y. So we've got that made as well. And I find out, if I plug back in that this is 40, I find out that this is also 40. And I'm looking to check my work up here. And I get 3 times 3 is 9 plus 2 is 11. And 3 times 5 is 15 minus 4 is also 11. So I've checked my work in both cases. Hopefully this is going well. Now, consecutive angles. This is another property. We just worked with opposite sides are congruent. Consecutive angles. Now, if I'm looking at this, I've got to consider my consecutive angles. So we are here. We're going to take this up, and we got consecutive angles, and I'll give myself a pointer. And I've got the angles of a polygon that share a side are consecutive angles. So if this is my side, angle A and angle B are consecutive. This is the side we're sharing, angle B and C are consecutive. This is the side we share, C and D are consecutive. If this is the side we share, D and A are consecutive. So that's the definition of consecutive angles. In the diagram, A and B are consecutive angles because they share a side segment AB. The theorem below uses the fact that consecutive angles of a parallelogram are same side interior angles of parallel lines. Same side interiors. Well, you got to think about it. If I've got parallel lines going through and I have a transversal, these two angles are same side interiors and they are supplementary. Okay, now we can talk about that same side interior and supplementary relationship for each thing, and they are right here. So we've got to make sure we recognize that, but let's talk about if a quadrilateral is a parallelogram, then its consecutive angles are supplementary angles. So we're looking at same side interior angle relationships for these. So now I'm just going to use same side interiors when I'm be able to solve for things. So now we're on to find out some stuff. So here, find the value of x. Well, since I know that these are parallelograms and these are same consecutive angles, I can use this idea of same side interiors. So 60 plus x is equal to 180. So I know x is 120 degrees. Okay. I also know that since this is a parallelogram here, that these are same side interior angles. Okay, so x plus 154 is equal to 180 degrees. So I subtract 154, I find out that x is 26 degrees. Now, in C, I have been taking the consecutive angles and using the idea of same side interiors. Well, these two angles are consecutive. So I've got 8s plus 5 plus 3s plus 10, and they will equal 180 degrees. Now I've got 11s plus 15 is equal to 180. I've got 11s is equal to 165 as I subtract 15. And I know that 11 times 15 is 165, so s is 15. So I've got 15 is s, x is 26, and x is 120. So keeping that in mind as we're working through these, we've got to make sure that we're comfortable with knowing same side interior angles. Our next property here, see if we can get this going. Our next property is talking about the fact if a quadrilateral is a parallelogram, then its opposite angles are congruent. So if I got a parallelogram, opposite angles are the same measure. Well, this is pretty slick. That's all I got to say when I do this. If opposite angles are the same measure, find the value of A in each parallelogram. So I'm going to find the value of A. So if opposite angles, and this is a parallelogram, are the same, that means that A is 10. Your turn. Do B. Wow. 3A equals 114. A 29. That's, oh, nope, 3. 3, 24, 8. So it's 38. So A is 38 there. All right. And then the last one, opposite angles. These are opposites. This is opposite this. 40 is equal to 3A minus 5. My opposite angles are diagonally across from each other. I add 5 and I get 45 is equal to 3A. And I find out that A is 15. Okay. So our next one, We get going here. If a quadrilateral is a parallelogram, then its diagonals bisect each other. Diagonals are bisecting each other? No way. Well, the diagonals are mutual bisectors of each other. So they meet in the middle, and A to E, C to E are congruent and therefore equal. B to E and D to E are congruent and therefore equal. So when I'm working with them, I've got to make a decision about what's happening here. So I've got to be able to look at my diagram, realize this is a parallelogram, and know I'm going to be able to find stuff, okay? But now, I've got this as 3D, and this is the same length, but I don't know this. I do know these two, and because of these two, I can set them equal. This is here to confuse us. So I've got 2D plus 1 is equal to, isn't it amazing? I put it right in my way, D plus 3. Now I just solve. I'm using properties of parallelograms to set up my relationships, and now I use algebra to solve. So I subtract D from both sides, subtract 1, and D is 2. Well, I plug that back in to check, and that's 2 times 2, which is 4, plus 1 is 5, and this is also 5. And now because it's D, I know that this is 6, and this should be 6 as well. Now it's your turn. Go ahead. Turn me off and give it a try. Welcome back. Remember, some of this is you identifying which one's which, okay? All right, so I've got 2h is equal to h plus 5, okay? Well, I subtract and h is equal to 5. Well, that means this is 10, and this is 12. And this would also be 12, since it is a parallelogram and diagonals bisect each other. Your turn. Go ahead. Okay, remember you're supposed to turn me off. Okay, the relationship 4j minus 19 is equal to 2j plus 3. I subtract 2j and I get from 4j and I get 2j minus 19 is equal to 3. I add 19, I get 2j is equal to 22, and j is 11. Now, last one. Let's see what we got. Find the values of x and y in the parallelogram at the right. What are PR and SQ? So now you've got to check out what's going on here. Do you remember systems of equations? No way. Y equals x plus 1. 3y minus 7 equals 2x. Where I see y, I can pop that in. So 3 times x plus 1 minus 7 is equal to 2x. 3x plus 3 minus 7 is equal to 2x. 3x minus 4 is equal to 2x. Now, I've got negative 4 is equal to negative x after I subtract 3, and I take that opposite of that, and I know that 4 is equal to x. Let's double check that to make sure that makes sense. When we plop that back in, and I know that y is 5. So if y is 5, that's 5, and x was 4, this is also 5. If y is 5, that's 15 minus 7, which is 8, and x 2 times 4 is 8. So I've checked my work. Now they ask me about SQ, and SQ is the whole length, so SQ is 10, and PR is the whole length, and somebody actually has to write PR versus RR. Maybe I think it's funny. But PR, the whole length is 8 plus 8, which is 16. So those are the things they asked me to find using my systems of equation skills. Now, we got another property here when we're doing this. And I want to make sure that you recognize this. This is kind of an extension of one of these. Theorem 6.7. If 3 or more parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. Okay, so remember, these 3 lines are parallel. They do not have to be anything more. You know, these 3 lines are parallel. And if I know this is true, if 3 or more parallel lines cut off congruent segments on one transversal, this is congruent and this is congruent, Then I know they cut off congruent segments on every transversal. So I know that BD and DF would be congruent, and that's what's going on here. Okay, so how can we use this? I've got a situation here where I know that AE, these are all parallel. Okay, AE, BF, CG, DH, they're all parallel. AB is equal to BC, which equals CD, and these are all 2. Okay, now, and EF is 2.25. Well, that means I know that this is 2.25 and this is 2.25 from theorem 6.7. Okay, that's what we just read. Okay, so now I can answer this question, what is EH? Well, EH, E to H, has got 3 2.5 segments in it. So 3 times 2.25, which is 6.75 units. Okay, so that's how long that would be. Now our summary today, keeping in mind, our objectives, students will be able to use relationships among sides and angles of parallelograms and use relationships among diagonals of parallelograms. Remember, the sides of a parallelogram, opposite sides are congruent. The angles of a parallelogram, opposite angles are congruent along the diagonal, opposite directly across from each other on the diagonal. Consecutive angles are supplementary. And then when we talked about diagonals, the diagonals in a parallelogram are mutual bisectors of each other. Write a couple sentences about something that you learned today about the learning objective, then rate yourself. But before you go, find those 3 things. Go. Okay? Hopefully you recognize that this is 15, this is 6, and this is 5. Straight up, those things are there. So DC should be 15. BC should be 5, and DB should be 12. Again, if you got questions, seek out your local geometry teacher. I'm Mr. Bloom, and you're not. Have a great day.